Good morning, class. Today you're gonna learn this lesson a little bit differently. As you can see, I'm not here, but you should be able to follow this lesson. Make sure that you have a handout and also a TI-84 in front of you so you can follow along. We'll begin with the first slide, which you know is always the objective. You can read the objective. This lesson is going to be slightly challenging, but I trust that you should be okay. You can do this. The vocabulary. Just kidding. I know you guys can do. I know you can do this, even though I'm not here. Let's go to the next slide. Don't get confused by what this table is telling you. I'll clarify it for you. Basically what this says is that you should be able to find any angle measurement using a trig ratio, okay? Which means that you're going to have to learn how to use one of the keys on your TI-84 that you haven't used. To kind of clarify this idea, let me show you this. If you were to punch in sine of 30 degrees into your calculator, you're going to get 0.5. Try it real quick. As you're doing this, you know that 0.5 is equal to 1/2. Okay? That's why you see that or 1/2. But now, this is the problem that you have. And this is what you're going to have to do later on in this section, on this lesson. You're going to have to compute, you're going to have to tell me what sine of an angle is equal to 1/2. Okay? Now you know that it's going to have to be 30 because I just showed you that sine of 30 is 1/2 or 0.5. But what happens if you don't have that? Well, what you're going to do is you're going to be using the TI-84. And to find that angle, you're going to have to use the inverse functions. You see where it says sine in the -1 power, cosine -1 power, and tangent on -1 power of x in the slide. We don't read it as sine to the -1 power of x. We call that sine inverse of x, cosine inverse of x, and tangent inverse of x. So if you want to find sine of an angle that is equal to 1/2, you want to be using the inverse functions. So the inverse function that you want to use for this case is you want to use sine inverse. So if you punch in second into the calculator, I'll wait for you to get there. Second, and then right above the sine key, you should have a sine inverse key, which is, I believe, is, to me, it looks like purple color key. And it has a sine and then to the -1 power. But again, we read that as sine inverse. And this is what you should have on the calculator. Sine inverse 1 divided by 2. Press enter and it should give you 30 degrees. So this is how you use the sine inverse function. You can also use a cosine inverse function and the tangent inverse function. And just to bring the point home, look up here and make sure you read that. Okay, so whenever you use an inverse function, you know that the calculator is going to give you back an angle measurement. Okay, let's go ahead and go to the next slide and practice using those inverse trig functions. It says use your calculator to find each angle measured to the nearest degree. Go ahead and get your calculator ready and punch in cosine inverse of 0.87. On the screen, you should have something that looks like this. 29.54 and more decimals. But keep in mind that we're rounding to the nearest degree. So the answer that you should provide is 30 degrees. In the same manner, go ahead and punch in tangent inverse of 0.71. On your screen, you should have the following. And then we round, and you only give me 35 degrees as your answer. And again, to emphasize a point, inverse strict functions generate angles. So whenever you're looking for an angle, you need to use the inverse strict functions. Let me go ahead and go to the next slide. Here there's some practice, but since I'm not there, we're actually going to do this together. It's basically the same directions as number 1. Now notice that on problem A, now you don't have a decimal, you have a fraction, but nothing we can handle. So go ahead and hit the tangent inverse or into the screen, and then you're gonna punch in the 3/4. Press enter. After you round to the nearest degree, you should agree with me that the answer should be 37. Letter B, now we're using sine inverse. Notice that B is a decimal, not a fraction. So just punch it in just the way it is. Wait a little bit. And that is your answer, 42 degrees after you round. And then the last one, go ahead and compute that. Now we're computing cosine inverse of a fraction again, not a decimal. And you end up with 66 degrees. Let's go on to the next slide. More practice, but in this case, the way that you're going to find the missing information is the same way as number 1 and 2. You just need to get used to the notation, okay? The way that you set up the equation. If you look carefully at letter A, you have tangent of angle A equals 1/10. Your goal in this problem is basically to tell me what is the measurement of angle A. Since we're looking for an angle, I know that I'm going to have to use the inverse strict functions. And the way that you compute this, go ahead and copy this first one. You're right. Measurement of angle A equals, and then at this point you jump to your calculator. You do tangent inverse of 1/10, and it should give you back 6 degrees. In the same manner, we want to find for letter B the measurement of angle K. So then we do measurement of angle K equals sine inverse of 3/7, and you get 25 degrees. If you try to do letter C, go ahead and do it. So we're looking for angle R. So you have cosine inverse of angle, because I have 3 degrees, cosine inverse of 3. And the calculator should read something funny. On this screen you should have error, domain, and some other 1 and 2, quit, go to. Basically what this is saying, that this is not possible. Next time that I see you, just remind me of this and I'll clarify why this is not possible. But keep in mind, sometimes you do get this when you're trying to compute some angles. Okay, so here's going to get a little bit more challenging on the next slide. but you should be able to follow along. So in this case, problem number 4 is asking you to find the unknown measures and round lengths to the nearest hundred and an angle measure to the nearest degree. So keep that in mind as you go through the problem. Different type of rounding depending on the length is hundreds, angle is degree. So if you look at the picture, you're missing ST, you're missing the measurement of angle R and the measurement of angle T. I'm going to show you how to do this 2 ways. Okay, the first method is basically going to involve you using something you learned in Algebra 1, which is what we call the Pythagorean theorem. And you should agree with me that this is what you get when you apply the Pythagorean theorem. Once you punch 5.7 square into the calculator and the 5 squared, which you already know is 25, and you solve for ST squared, this is what we have. And then at this point, you punch in 32.49 minus 25 into the calculator. You can just trust me on this. You're going to get 7.49, and then we're going to have to take the square root of that. And if you were to do that with a little more time, or maybe you did it, this is what you get after you round the length to the nearest hundred, 2.74. So we already have ST. Now our goal is to find angle R and T. I'm going to find angle R first. And I'm going to use the definition of cosine. Notice that since I'm looking for angle R, I already have adjacent side, which is 5, and the hypotenuse, which is 5.7. So then at this point, I can use what we did on the previous slide, problem number 3, and I have measurement of angle R equals cosine inverse of 5 over 5.7. If you punch that into the calculator, I'll wait a little bit, and you round to the nearest degree, because now we're looking at an angle, you should agree with me that the answer is 29. In the same manner, now we're going to find angle T, but we'll have to use the inverse strict functions. All we're going to use is the fact that angle R and angle T are complementary. So 90 minus 29 gives me my angle T, which is 61. Method number 2. It's a little bit different. We're going to start out by finding, again, measurement of angle R. And we did that on the method 1. You should be able to follow why we get that. Once I have 29, I'm going to be using that eventually. I can write that on my drawing on the acute angle R, 29 degrees there. And then I can very easily find angle T in the same manner that we found angle T on method 1. T and R are complementary, you get 61. Now the only part that I'm missing on this right triangle is ST. The way that I'm going to find ST is by using one of the trig ratios. And in this case I'm going to use sine. So then this is what I have if I use sine. And my reference angle is going to be 29 degrees. So sine of R, sine of 29 degrees gives me ST over 5.7. Once I cross multiply and substitute for R 29 degrees, I get the following. Punch it into the TI-84 and it should give you 2.76 after you round the length, again to the nearest hundredth. I'll wait a little bit so you can copy this down. I just want you to pay attention to this part. In method 1, notice that ST is 2.74. In method 2, ST is 2.76. It's a little bit off. Don't worry, either method on the test should be okay. If you're a little bit off, you should get full credit for the problem. Okay? Let's move on to problem number 5. And again, another example. I'm going to guide you through this one as well. It says same directions as number 4. You want to round a length to the hundredths and a degree to the nearest degree. So the first thing we're going to do is we're going to find the measurement of angle D. Since you know that F and D are complementary, you know that we can get 32 by performing the operation that you see there. Now at this point, I want to find EF, length EF, and I'm going to use the reference angle 32, and I'm going to use the side ED or 14 units. So I'm using reference angle 32, I'm looking for EF, and I have the adjacent side 14. What we need to do is use tangent at 32 equals EF over 14. You should be able to follow the definition of tangent. At this point, you want to solve for EF, so all we need to do is simply multiply. And once you have that, punch that into the calculator, you should see that you should get the following decimal once you round to the nearest hundredth. Now all we need to do is find DF. To find DF, I'm going to use a reference angle of 58, and I'm going to use the units that they gave me, the side of 14. So sine of 58 gives me 14 over DF. Once I have this, I know I can solve for DF because I have one unknown. You did this on the previous section. So we cross multiply, then we divide, and what you're going to have to compute to find DF is 14 divided by sine of 58 degrees. I wait for you to punch that into your calculator. And then at this point, you should agree with me that this is the decimal that we get when we run to the nearest hundredth. Since I'm not there, these two practice problems, you're going to work as a group. I don't mind if you move around, just like when I'm there, as long as you're working on the problem. I'm going to give you the answers on the PowerPoint, and you can just verify that this is what you're getting for number 6 and number 7. If you're having a little bit of difficulty, you can talk to your neighbor or somebody in the class. I'm sure that there's going to be plenty of people that can generate those answers. At the end, at this point, I'm going to stop, so you can continue to work on this. Once you're done with 6 and 7 and you have those answers, go ahead and get the book and start working on section 8.3 or homework number 3 on your homework log. Good luck, and then I'll see you on next time.